Hello everyone, welcome and thank you for watching this video. Today, I will be showing you how to make a procedurally generated 2D world in Unity using my Gridmap Maker. I will start by showing you various procedural maps being generated in real time in order to show you what is possible. Alright, so let's first of all clear this map, okay? And now I'm going to put on the print time, that way you can all see how fast these maps generate. At the current moment, we will be making a 100 by 100 map, okay? So that's all we're gonna do, and we're using the size just for speed. So let's see, as you can see, let's generate this. Let's make an instant update. This way we can see our updates in real time. We can then come down to our noise generator down here, and we can just begin to generate whatever map we want extremely fast. And as you can see, it's all of that. You can use various noise functions to generate whatever map you want. Let's see if we can increase the rain. That it gives us different, deserts and whatnot. We can make it more, more deserty or more green, various things. And let's say temperature. We're gonna actually reduce the temperature. More snow, less snow. Make the seed differently. As you can see, there are a lot of options we can use here in order to generate whatever map we want. Let's reduce the frequency on this one more time. Makes it look normal. Do this. We can even change the noise type of noise, and different noises give you different values, right? So it really depends on what exactly it is you want, right? What kind of noise, what kind of map do you want? But the point of this is to show you how customizable this is, right? How fast it is. So, what is the Gridmap Maker? The Gridmap Maker is an API for dynamically creating customizable grid or tile-based maps. It is made for those who want more freedom and customizability when dynamically creating their maps. I made this API in order to overcome some limiting factors of Unity tile maps. Unlike Unity tile maps, which only support sprites and colors, Gridmap Maker supports sprites, colors, textures, and most importantly, materials, allowing you to run individual shaders on individual tiles. Before us, we have two objects. On the left, we have my grid map, and on the right, we have a plain mesh. I have made two shaders here, a water shader and a lava shader, using shader graph. And you will now see that both of these shaders can be placed on top of the grid map as you normally would with a plain mesh. Right now, the water effect is being shown on the grid map and on the plain mesh. But notice how we can easily place the lava shader on top of the plain mesh, but also on top of our grid map. Very easily. Very, very easily. My Gridmap Maker also allows you to create your own custom shapes with your own unique UV mapping. Currently, our grid map is made using hexes, as you can see, but we can very easily make this using rectangles. I have already created these rectangles off screen, and as you can easily see, I can generate my grid map using squares and rectangles. The grid map also has a layered system, so you can create individual layers and stack them upon one another. In the following grid map, we have two layers, the base layer and the snow layer. These two layers are completely independent of one another, as you can see here. Now that we understand that we can use shaders or materials to tile our shapes or hexes, let us see how our shader works. Before us is a land shader. This shader takes in two values, rain and temperature, and these temperatures determine the kind of biome we will have. I have conveniently brought these two values down here so that we can see the input and the output. On the left is rain, is temperature, and on the right is rain. So if I make both values go from 0 to 1. So if the rain is 1 and temperature is 1, we have a very bright green. However, if there's no rain and there's all temperature, we have more of a desert look. Subsequently, if there is absolutely 0 temperature but a lot of rain, we have more of a dark, moldy swamp. And by modifying these values accordingly, we can give our map a certain feel and look. Now, I will explain to you how we generate noise. Noise is used to generate random natural looking values. At the current moment, our noise value is taken from the following script. The Fast Noise Lite is a free noise generator provided on GitHub. If you look up this particular script on GitHub, you will find this script. And this script provides us with a variation of noise types and noise values in which we can use to generate our map. Our noise generator utilizes these noise values in order to generate a land, rain, and temperature noise values. By modifying these values and by modifying our noise values, we can generate any map we want. Next, we have our biosphere class. The biosphere class simply takes in the three noise values, land, rain, and temperature, in order to determine what particular biome or visual data will be assigned to a particular hex. We have two other shaders I have not shown you guys, and I will not show you to save time. We have our snow shader and we have our lava shader. When we examine our scripts, we can examine these methods. The two main important methods here are the get snow biome and the get biome methods. The get snow biome takes in the temperature noise value and determines whether or not, if it's below the snow threshold, we then generate a snow value. We then pass in the snow value into our snow shader to be made. The same thing with the get biome method. The get biome method takes in the land, rain, and temperature value, and based on these values, we then determine whether we should send back an ocean material, an ocean shader, and a lava shader, or the land shader. A very important property of our biosphere class is the rounding factor. The rounding factor allows us to round noise values to specific numbers so as to limit the amount of unique visuals in our map. Examine for a second the current rounding factor of 38. This produces 51 unique visuals. However, if we were to remove this number, if we were to lower this number down to 12 or 14, and we were to draw our map would now have 134 unique visuals. And that is because the visuals will easily fluctuate towards the next biome. Once again, observe. If you go back to 38, you see? Less fluctuation. However, when you round down to say 0.1 to 1, more fluctuation. And the way this rounding factor works is as following. We have a rounding factor of 1, that is 1 divided by 0.01. That means a 0.94 noise value will be just 0.94. A rounding factor of 50 means round to the next 0.5. So that is 0, 0.5, and 1. That means a 0.3, a 0.384 will be a 0.5. And this is how our rounding factor works. By utilizing our rounding factor with our shaders, we're able to limit the number of batch counts in our map. Notice how a rounding factor of 1 produces over 1,900 batch counts. Meanwhile, a rounding factor of 50 only produces 35. Now that we understand how the map is made, it's simply a matter of bringing everything together. First, we have the Grid Manager. The Grid Manager is the main component for the grid map. We have the biosphere and also we have the noise generator components. We first have to reference these components from the editor, and we do so in these following methods. After that, we then have to compute the noise. But when we use the noise generator, we can compute the noise values for the grid using the grid size. So if we're generating a 10 by 10 grid, the noise generator will create a 10 by 10 mod 2D array with all the noise value. And these 2D array will represent the particular grid location on the map. Once we've computed our noise value, we then have to pass these noise values into the biosphere. The biosphere will get the noise value for each grid point and determine what particular visual data will go to that grid point. Once that is done, we then save the visual data that we have retrieved into a dictionary that references a particular grid point to a particular visual data. Once that is done, we can then come and generate our grid very easily. We simply loop through the entire planet, access the biosphere, and get the visual data based on that grid point. We now understand how the four main components of our map come together in order for us to create a procedural generation world. Let us now explore this further and see the kinds of maps we can generate. So over here in the scene view, we can generate, let's assume, a random, increase the land. We can come down. Let's say we want it to be a more colder planet, so we reduce the temperature. Maybe we don't like the weather's at, so we can change the frequency, change the seed. Maybe increase the frequency just a little bit, change the seed some more, increase the frequency so it happens all over the planet. And maybe we want more deserts, so we reduce the amount of rain to create more deserts. And we increase the temperature, and so now it's more deserts, more lava. Maybe we want more land, right? So we increase the number of land. Maybe we want less land. Maybe we want more islands, so we change the fractal type, so you have more islands and whatnot. Increase the seed. Maybe we can do something like a ping pong where it's more wavy. You have more long stretches of land, and you can notice how we can bring all these together to create whatever map we want. Very quickly, I want to show you that the Gridmap Maker can actually save your map. Now, if we have, for example, this map over here, and we wanted to save this map, what we could do is that we could save the noise values and then use these values to then regenerate the map. That's perfectly valuable. However, the Gridmap Maker can also just save the map itself. So if we have this random map here, let's say this map, we can actually just save this map, right? And let me have a picture here, a screenshot, just for reference. We can actually just save this map, generate a completely random new map like this one, and then notice the noise values don't actually change. And then boom, generate the old map we had saved, right? Let's do it again. Let's create a completely random new map. This one. Let's do something else. Let's do something like this. Let's just increase the noise value. This one. Again, hold a screenshot. Here's our screenshot. We save this map. It's saved. Generate a random value again. Random map, and boom, the map we saved is still there. This is the power of the Gridmap Maker. Well, thank you guys for watching this video. I hope you found it useful, and check out my Gridmap Maker on the Unity Asset Store. And I hope you have a good day. Thank you.